Welcome to OmegaMatters, where we talk all things omegas. I'm Kristina Jackson. This is my dad, Bill Harris. And today we have a guest from across the pond, Dr. Matthew Sprague. Matthew is a lecturer in nutrition at the Institute of Aquaculture at the University of Stirling in Scotland. And OmegaQuant has a special connection with the University of Stirling and their aquaculture unit because they help run our omega-3 index testing and their lab over in the UK. So we have a lot of connections, and this is just a great group to work with. And they have the extra bonus of their experts in fish and aquaculture, and we're going to talk all about that today. Thank you so much for coming on. Let's start off with the news that you tested your omega-3 index recently. What did that look like?
Yeah, so it was the first time in over 2 years, and as I was saying previously, it was 7% 2 years ago, so which is quite good, obviously.
Pretty good, yeah.
Yeah.
Oh, yeah.
So, I decided just to up my seafood intake and got it measured the other day, and it came out just over 10, which I think is unbelievable.
It's very good. It's very, very, very good.
Yeah, because, I've been obviously following your work as well and the publications, and from what I can recall, you're suggesting it's probably about 1.3 grams per day recommended to get over the 8%, which is a heck of a lot if you need to do that, because if you actually consider how much EPA and DHA there is in the world, there's not enough. It's probably about 1 million tons. I think Douglas Tocker, a retired professor, done this, calculated back in 2015, and he actually came out as 1.2 million tons, of which is what's required if each person, 7 billion people, were consuming half a gram a day. Now, okay, so but actually the supply is only just over 0.8, 0.9 million tons. So there's a shortfall, and that shortfall probably equates into, at least on the 7 billion population, obviously the population is 8 billion, there was probably around about 2 billion people going without any EPA and DHA in their diets.
Yeah.
It's just not enough. So, yes.
Wow, interesting. So tell us about your diet. What fish do you eat? And is it every day or?
No, it's not every day. I try to have it, the recommendations are for 2 portions of fish per week, of which one of those should be oily. So I normally meet this. However, I've kind of upped it and maybe 3, maybe 4 portions. Now, this is where we also fall down here as well, because portion sizes vary between different countries.
Right.
So I think it's 4 ounces, which is 112 grams in America. Over here in the United Kingdom, it's 140 grams. So there's a big difference there. European Food Safety Authority was, for Europe, is 130 gram recommendation.
Of course.
So that's the first sort of pitfall here. There's no consensus on this. Then we've also got the no consensus on what the recommended intake for EPA and DHA should be per day as well. So it's a bit of a mind.
Yes, it is.
What kinds of fish are you eating?
So
3-ish times a week.
It can vary. Generally, my oily fish would be salmon, and obviously that'd be farm salmon. That'd be fine predominantly here in the UK. We do get the wild Alaskan species as well, but I generally have the farm salmon. I suppose I have to say that, being that I work.
That's right. That's what you got to say.
Shellfish, again, well, this is the other issue in terms of the portion sizes. What they sell in the supermarkets, it's not necessarily a portion, so it's not 140 grams. It can be something smaller in some instances. But yes, it's salmon, mussels, whitefish, so cod, haddock. So I try to vary it up where I can. Occasionally, I have mackerel, which is obviously really high in EPA and DHA.
Yeah.
But yes, it's again, I think it's all down to individual preferences. Some people don't like the high fat content, including in salmon as well. There's people that don't like the high fat content, and they may occasionally, if they're eating salmon, go for what we call the granny pieces, which are the tailpiece portions, because they contain less fat. Go on to that as well, how EPA and DHA varies throughout the fillet on the fish, as well as between fish species, etc.
Come on, and you don't take any supplements, is that true?
No, if unless there's any supplements lying around, it's literally precisely. If there's any around here, then I'll maybe take one or two. But no, it's just fish intake. I don't think I've had supplements for over a year.
Yeah.
Now, supplementation, as we know, supplementation really is just to supplement your diet. So I would always recommend personally to eat fish, because you're not just getting the EPA and DHA, you're obviously getting other nutrients. So you're getting a rich source of protein, you're getting your minerals, micronutrients, vitamins, etc., vitamin D. And again, these vary between different species. So like lean fish, for example, really high in iodine compared to the fatty fish. Vitamin D,
good.
Vitamin D, that's quite variable, what I've been noticing as well. It's not really correlated to fat content, even though it's a fat soluble.
How about selenium?
Selenium, well,
maybe we'll get into that.
Generally quite good. And this is the issue where we come onto the farmed fish as well. So, with the farmed fish, it's pretty much identical. Certainly for salmon, what we're working in, it's identical to what's happened with like the human population in terms of diet changes. We've increased the amounts of lipid, so amounts of fat that goes into the diet, and also omega-6. So there's a big increase in omega-6. Now, the primary reason that we've done this is because fish species, the marine carnivorous fish species, so the salmons, they require EPA and DHA in their diets. Okay, so freshwater species, you can get freshwater species that actually produce EPA and DHA, so they're much like ourselves, where they can take in just 18,3-3 alpha linolenic acid and linoleic acid, 18,2-6, and convert that into EPA and DHA. However, they don't produce large amounts. It's very, very tiny amounts. The marine species, unfortunately, they can't produce it. Salmon can produce a little bit. That's a separate story. But then again, it starts off in freshwater marine. But they require it in their diet. So these are actually EPA, DHA, essential fatty acids.
Oh, that's interesting. Not true in humans, actually.
Well, okay, yeah. So salmon are probably much the same in terms of the critical amounts they can make. But for human intakes, for our optimal health, no, they can't.
Right.
Okay, so they don't produce the large amounts. It comes through in the wild, in the natural diet. That comes from microalgae.
Okay.
So microalgae are the primary producers, and then everything else just accumulates and magnifies through the food chain.
So is the consumption of preformed EPA and DHA in these marine fish, is that what kind of shuts down synthesis from ALA?
Well, it's probably evolutionary terms in that the marine environment is just abundant in terms of EPA and DHA, so they don't actually need to make it. Because it's there in their environment and it's in abundance. Well, we'll probably have those extra steps when it's there and available for them. So, however, when it comes to farmed fish, we're supplying the diets. So those diets have traditionally been based upon protein sources as fish meal and lipid sources, fish oil. Both of those come from the wild captures fisheries. But as we know, the wild captures fisheries are stagnated or in decline, So as aquaculture is increasing, demand increases, but supply has just remained stagnant. So we need to alter these. So we've been changing the ingredients over the last 20, 30 years, and we've been changing these using vegetable sources mainly. So soya protein concentrate as the protein source, and rapeseed canola as the sort of one of the main vegetable oils for fish oil replacement.
Yeah. And this is where your work has really been important. Is tracking this, I think.
We've known, the industry's known this for a long time coming, and as you know, you are what you eat with respect to dietary oils, and that's what's reflected in the flesh of the fish. So whatever oil source we put in, it reflects. So what we've seen over the last 20 years in sort of farmed salmon is we've seen an increase in the use of alternative oils. And these alternative plant-based oils are devoid of any EPA and DHA. They don't contain them. They have the shorter chain, and the alpha-linolenic acid, but they don't have any EPA and DHA. So because of that, what we're seeing is the levels of EPA and DHA in the flesh of the marine farm salmon decrease.
And we're
we
talking
now
like
probably have to eat twice as much as what we used to in 2005, for example.
Mm-hmm.
Right. So you eat a fillet of salmon in 2005, you're getting about twice as much EPA and DHA in that cut of salmon than you are today because of the fish feed, which directly really messes up the recommendations and our epi, and all of this gets greatly impacted by that.
Yeah, it makes a good case for measuring your blood levels.
Yeah,
it does.
It's not you can't avoid it because it comes from the wild captures fisheries. As I mentioned, they're stagnated, so there's not enough of that oil. So we have to replace. And unfortunately, we're trying to meet the global demand for seafood. So increased population, increased demand for seafood. So we're supplying them with this farm salmon or farm fish. But unfortunately, those farm fish, because their natural diets are dependent upon the wild captures fisheries, and there's not enough of it, we have to replace. And sadly, that's what happens, is that we see the levels of these EPA and DHA go down. So we have to eat more.
Are the levels steady in wild caught salmon?
Yes. So this is one of the issues in terms of, they're also in decline. It's naturally in decline. Fish farms are usually one of the sort of the bad guys who are automatically assumed to be causing this, but not necessarily so. I mean, they've been, even before farmed salmon started in the 1970s in Scotland and Norway, wild fisheries like the sea trout and farmed wild salmon, were automatically in decline anyway. Obviously, that's not to say that aquaculture isn't having an effect. It probably is in some, but there are other issues going on as well. But in terms of EPA and DHA levels, they're probably around about 1 gram per 100 grams EPA, DHA. Fat content is lower, but we have to remember when it comes to wild fish, particularly the salmon, who start off in the freshwater and then they go to the open marine water where they feed up in the open ocean grounds, which we don't readily access. They feed up, they produce all that extra reserve of fat content in their flesh, and then they decide to come back home to spawn. So during that spawning process, all those lipids, all the fats that they've accumulated are then mobilized into gonadal development for reproduction.
Nice. Yeah.
But also the energy itself is being used for that homeward journey. So when we do catch them, when it's a bit easier as they begin to get towards the rivers and we catch them there, that fat content's come down. So there's usually an issue that farm salmon are much more higher in fat than wild salmon. It is true, but it doesn't necessarily mean that the wild salmon can't get to those fat levels as well.
Yeah. Oh, that's interesting. Does the feeding of more and more vegetable oil in the farm salmon change the taste?
There have been organoleptics. There may be slight changes in taste. It depends on the inclusion levels of certain ingredients. So producers will always try to mitigate against this. But I think one of the major things is whilst, as I mentioned, salmon have requirements for EPA and DHA in their diet, and it's normally around about 1% of the diet. Again, it's like humans. They require EPA and DHA if we want to make them more robust for optimal performance, and particularly in challenging conditions. We find if they have higher levels of EPA and DHA in the diet, they're able to perform much better than those that have lower levels.
It's healthier for them.
It basically just mimics the human story.
Things run better. So we have to replace calories, fat, protein in the diet. They're also the algal EPA and DHA that are being grown in tanks, even here, like in the middle of the US.
Yeah.
That's being used in aquaculture to increase
Yes.
levels. Is that right? How's that going?
So that was predominantly developed for aquaculture, because the growth in aquaculture, obviously the investment going in, it's seen as being profitable. So one of the big stories was this decline in EPA and DHA levels. So a company called OmegaMatters, which is really from DSM, using their algal strains, which had, most of the algae that went before were just DHA rich only. So a lot of the technology has actually come across from the infant formula.
Right.
So this is all grown using heterotrophic fermentation units. Big units requires energy sources, carbon sources to feed the algae, and then they produce the EPA and DHA. However, it's all about species strain selection because, what you're looking for at the end of the day is a microalgae that really has these fatty acids. It's all good and well that they could be 60% of the lipid, but if you only have 1 gram of lipid, 1% lipid, you're going to have to produce a lot of that biomass to extract enough EPA and DHA. So you're looking for a high lipid content. You're looking for, these fatty acids being present and in high numbers. So, this has been developed and it's actually being used in the aquaculture and the salmon industry at the moment.
Back to the microalgae, do they actually feed salmon the microalgae as a biomass, or do they extract the lipids and just use the lipids?
So for this OmegaMatters one, they actually extract the lipids. However, the extraction of the lipids is quite a costly procedure and, quite intensive. So it increases the cost more. You can use the biomass, and we have used the biomass in the past. However, in aquaculture, when we're making feeds, we like either something to be like a protein source, like a meal or an oil. The biomass is a mix of it. So when it goes into an extruder, there's a certain amount before it then begins to clog up and cause issues.
Oh, really? Interesting.
So, ideally having an oil source is much better. But as we know, when you break open, which is really tough to break open the microalgal cells, they're obviously more prone to oxidation as well, the EPA, DHA. So, it just increases the cost. And
that makes sense. So one of the papers that I've always go back to from you is from Scientific Reports in 2016, which is almost 10 years ago now. But it just has all those really practical graphs about how many fillets of salmon you'd need to hit the same EPA and DHA. So the name of that for this purpose is Impact of Sustainable Feeds on Omega-3 Long-Chain Fatty Acid Levels in Farmed Atlantic Salmon 2006 to 2015. That also has James Dick on there, who's the lab lead that we work with. Do you have an update on that paper? Is that what's been happening since 2015?
Not really. I've been monitoring the levels. There's been a paper recently from Norway, more or less showing the same pattern. So Norway, or what we call the global powerhouse production of farmed salmon, they're 1.3, 1.4 million tons. Scotland is probably about 7 times smaller. Okay. So there's data to show that in 1990, for example, the farmed salmon feeds used in Norway were around about 90% marine ingredient inclusion. All right. In 2020, it's down to about 20% marine ingredient inclusion. So that's fish oil. And that's because of the growth of aquaculture, but also the lack of supply of these marine ingredients, which we've had to replace. So what's happened is we've seen the levels of these EPA and DHA come down.
So are they continuing? Are they kind of steady from still about half? Or do you know?
I would say they're about steady at the moment. Okay, we've kind of got that plateau. And to be honest, if we go any lower, then there's going to be impacts on like fish health as well. So because there's, as I mentioned, requirements of the fish themselves and how much we have to include in the diet. So we can't really go that much lower. Mm-hmm. But however, there are, you've already mentioned the microalgae, there are other options. So, in Scotland, for example, as I mentioned, we're 7 times smaller than Norway. And that means we can be a bit more bespoke to how we use marine ingredients, because Norway basically just follows that one pattern. Scotland's following the same pattern in the decline of EPA and DHA. We're usually a couple of years behind because we're smaller. Mm-hmm. But you can get divergence in production strategies. So you can have a farm that wants to, or a retailer, for example, that wants to produce a salmon which is rich in EPA and DHA and sell it for the healthiness. So they will still include a high fish oil, but you may have others which want to include more plant-based ingredients, purely either on cost or sustainability. So it depends on the ethos. It's not necessarily one is better than the other or one's worse. It's just different directions people want to take within reason, of course.
Can those products that are richer in omega-3, salmon enriched at higher omega-3 levels, can they advertise that or put that on the label?
In the UK, I think it's very low levels that you have to have of either ALA or EPA and DHA just to advertise it being high in omega-3 or a source of omega-3. The EPA DHA levels are incredibly small. Just to even state that it's a source of EPA, so that you can't get any distinguished nature between walnuts, for example. They can still say high in omega-3, and you can have the mackerel high in omega-3. You have to go to the back of the packaging to then look to see what it states in terms of EPA and DHA. And again, some labeling may just say omega-3, but doesn't state EPA and DHA. Some will actually say of which EPA and DHA is X amount.
Good. Yeah. I would think you wouldn't make a product like that if you couldn't advertise in some way that you've got a higher EPA DHA content. What's the point?
Yeah.
Exactly.
So this kind of leads into the idea of, how do people know how much EPA and DHA is in the fish, or what salmon or any other kind of fish when it's not required labeling? And also, are we getting to a place where it needs to say a fillet of salmon needs to have this amount of EPA and DHA per 100 grams to be considered a salmon? Are we anywhere? Would that ever be?
Well, so as I was mentioning, there's differences between sort of retailers or producers, so we say salmon producers, and they can specify what EPA, DHA levels they want in their product. Yeah. So even though you got farmed salmon, it's not the same. In one place, it can contain, let's say, 1.8 grams of EPA and DHA per 100 grams. In another farm site, or even on the same farm site in a different cage, which goes to a different producer or a different retailer, it may only contain 0.8 grams based on what's in the feed. So you really have to check all this different packaging. And then, as I mentioned, there's differences between the portions because, not very few of us buy a whole side of salmon. We often get it into the different sections, the different portions. So because the fat content varies from head to tail, if you go for a tail piece, you could be, 20-30% less EPA, DHA than one of the midsections, for example. And that's all down to the fat content.
Really, even on a per 100 grams of fish basis,
it's
actually
when
less
you
fat. There's just less lipid there in the tail.
Yeah, so let's say a standard salmon could be about 12% generally. If you go just behind the dorsal fin, if it's 12% under the dorsal fin, so the top fin there, that section, if you go behind it, that lipid content can go from 12 to 10%. And then if you take the tail portion afterwards, that could be sort of like 6% lipid.
So the percent EPA DHA is the same across the fish?
But no, the percent EPA DHA would change. So actually the tail piece has a higher proportion of the lipid as EPA and DHA. Oh. Now that's probably as expected because it contains less of the storage lipid, triacylglycerol, and it contains more phospholipids. And obviously you want EPA and DHA in your phospholipids because you want you don't want a rigid cell. You want that cell to be more flexible to allow the movement across the cell membranes.
Yes. So what percent of the EPA and DHA in salmon is in triglyceride versus phospholipid? 50-50?
That's a good question, and probably off the top of my head, I can't answer that one.
That's okay. I don't know either.
The triacylglycerol are normally reflective of the normally much more reflective of the dietary oil source. Yeah. Phospholipids can be, but obviously there are selective fatty acids. So, arachidonic acid, omega-6, but also EPA and DHA. Yeah. Their exact proportions is something I'm not.
Is there an adipose tissue in salmon? That they have fat tissue? Not just. Yes, yeah. It's not stored in the muscle as triglyceride.
No, they're all the adipocytes as well. Yes.
Okay. Is that right under the skin?
Well, you get the white muscle, and you get the red muscle as well. So the red muscle is the very small bit of muscle that runs down the flank, and that is your day-to-day energy. The white muscle, which is the main storage, is essentially what is the fight or flight muscle. So it's the anaerobic.
Okay.
Well, yeah. So when I have wild sockeye salmon and a farmed Atlantic salmon, and I bake them similarly, the wild one always exudes a little white. It's drier, and then you can see like white fat coming out of it. Is that these two different?
The white is normally the protein.
That's the protein.
Yeah. So we actually, and I need to publish this piece of work. We took salmon from the same cage. So, because this is one of the issues, people have looked at the effects of cooking on things like EPA and DHA levels.
Yeah.
So we took salmon from the same cage. We took salmon of the same size, because size will influence the lipid content. Lipid content is then going to affect the EPA, DHA, etc. Right. So we had fish of harvest size. Harvest size can be anywhere between 3 to 6 kilos, So I think ours were around about 4 kilos, all fish. We then took off the left flank and the right flank. So left side was going to be analyzed raw, as is. The other side was going to be analyzed by a different cooking technique. We then actually separated those sides of salmon into separate sections. So looking at the different pieces. And again, as I say, subject them to different cooking methods. So we done poaching, frying, oven cooking, baking, smoking as well. What we didn't do was to add any culinary oils, because if you add culinary oils, that's going to affect the fatty acid profile. So we didn't want to do that. Now, what you find is when you actually compare these two, if you normalize it, so grams per 100 grams, you will find that the cooked has higher lipid content and has higher EPA and DHA content. Okay. However, you have to remember, you take 140 grams or 100 grams of salmon. Okay, I've analyzed that raw, so I should be producing the results as per 100 grams. If I take that same piece, I then cooked it, and then analyzed it, there's going to be weight loss.
Yeah.
That cooking loss. So the moisture is mainly one of the main cooking losses. If you actually report the data, 100 grams and 100 minus X, whatever the cooking loss, EPA, DHA levels were similar.
Okay.
Cooking does not destroy
EPA, DHA.
Any of those methods anyway.
Yeah, virtually all the methods. We tried 7 different cooking methods. The only one we couldn't do was the smoking, because smoking, you intentionally add the salt for the curation, etc. So that was difficult to do the losses, but it would be more or less the same. There was no difference. And where there were differences, again, they were only minor. So cooking doesn't really have an effect.
Good to know.
Good.
Good to know.
That is really good. So I think we have hit a lot of this whole process that we wanted to hit. So I guess I have two questions that I'd still like to ask. One is, what should consumers do as far as fish intake goes? What do you recommend for people to do for fish intake?
Okay. Well, here in the UK, as I mentioned, it's 2 portions per week, of which one should be oily.
Yeah.
So another study that I've been looking at recently is looking at basically nutritional composition of the seafood we can buy here in the UK. So this has been going on for a few years now.
Mm-hmm.
So as I mentioned, the UK with those 2 portions, they do state that those 2 portions should provide 0.45 grams of EPA and DHA per day. So this was something that sort of got me thinking a few years back. Does it really? Has anyone actually checked it? And I don't like to go on a daily basis. I always like to present on a weekly basis. And the reason I present EPA and DHA on a weekly basis is because we're taught to eat portions of fish twice a week. And really, our only intake is coming from seafood. Mm-hmm. So that would equate to about 3.15 grams. So that was my benchmark, really. And then looking at the 140 grams, as I mentioned, being a portion is what's recommended in the UK. So when you look at, I think it was around about 97 samples. So when I say samples, are different seafood types. Mm-hmm. However, within there, I also had farmed and wild of some similar species, so like the salmon, turbot, sea bass, etc. So the only one on average which would give that 3.15 grams is Atlantic mackerel.
Yeah.
Everything else, you would have to eat at least 2 portions just to get over that 3.15 grams.
Mm-hmm.
So I think when I was looking at the combinations, first of all, I was doing combinations of any 2 portions. It could be oily, non-oily, 2 non-oily, etc., or even of itself. So mackerel versus mackerel. Out of the number of combinations, I think 90% were below EFSA, so the 1.75 grams of EPA and DHA per week, so the lower recommendation, which is obviously quite shocking. When you then took in 1 portion of oily, which was over 8% fat content, with 1 non-portion, I think it took it up to 70% still being below the 1.75 grams. So when you then change that to 2 portions of oily and 1 non-oily, pretty much every single one would meet EFSA requirements, so the 1.75 grams, the lower EFSA requirements. And I think it does go up to probably about 75% actually getting above the UK's 3.15 grams of EPA and DHA per week. So
you need to publish that.
You would really need to eat 2 portions of oily and 1 non-oily.
What are the top 5 fish consumed in UK?
UK would be things like it will be mackerel, but cod, farm salmon, tuna, so haddock. The other thing on tuna as well, tuna is often thought of being as a fatty fish species, and it does have high fat content. However, here in the UK, what we can buy in the retailers is really just the loin pieces, so that, like the shoulder, the back pieces. And you'll actually find that contains less than 1% fat. So, I mean, tuna contains high amount of DHA, but because it's got the low fat content, it's, all the fatty sections, obviously they go off to places like Japan where they're highly prized and, for the sashimi, sushi markets.
Yeah.
So albacore tuna, higher than chunk light? Not much?
Albacore and yellowfin are the 2 species we mainly buy in the UK. And as I said, both of them are exactly the same. You probably have to eat somewhere around about 20 portions a week to get the levels. Okay. Cod, for example, would be 11 portions per week.
Yeah.
Tilapia, which is freshwater, is probably around about 60 or 70 portions. It's a freshwater species. It's at the bottom. It's lower, But it's not as bad as the Pangasius. The Pangasius, the river cobbler, you would have to eat, I think it's around about 200 odd portions just to get 3.15. But we have to remember where they're grown. These aren't oily species for a start.
Right. They're not
and
supposed
where
to be.
they're grown as protein sources.
Yeah.
Right,
So
right.
it's
typically,
it's how you look at it.
freshwater fish generally are going to be very low in omega-3.
Yeah. As we mentioned, they do have the machinery to make EPA and DHA. That it's just that they can't make it in high amounts.
Right, right.
Whereas the marine species, particularly the high trophic ones, they can't make it whatsoever. So we have to.
And there aren't any microalgae in freshwater to produce omega-3.
There will be the phytoplankton, the microalgae. Yeah. So, but again, still, it's not in the large amounts that you find in the marine environment.
Okay, good to know. Good to know.
Again, it's all about the species and the types of the strain and the species and lipid contents, etc. So
it really is. And probably 2 to 3 servings of fish a week is the old 1 to 2 servings.
So I'm kind of surprised that Norway is such a. I mean, Canada, I would think, would be a big producer of farm salmon. Not true?
Yeah. So Canada, but mainly Chile would be
Chile.
Norway and Chile. Yeah, these two are probably the bigger nations, and then you got like Canada, Scotland, the Faroe Islands, but also down in Australia, Tasmania. As well.
But still, like 70% of the whole market is Norway.
The vast amounts, yes.
Okay.
It's the same with in Scotland, for example, we got like the Label Rouge fish, which is seen as better, the premium status, which is often gives it a higher priced premium value. But in terms of production, Norway well ahead.
Yeah.
In terms of the volumes.
Yeah.
Well, good for them. Okay.
Yeah. Yep. Well, we usually started off by asking how you got into this field in the first place. And I am curious, how did you land getting so deep into the fish world? I mean, you're in Scotland, so that probably had a lot to do with it. But can you give us a little background?
Yeah, my background is actually biology. So I was always interested in science, and I think I was always interested in research. So mainly biology and chemistry, those are the two subjects I really enjoyed at school. So when I went off to university, I was just, stuck in the sort of biological science degree. And then in my final year, when I was doing a project, it was on fish nutrition. And it was actually my supervisor down there that had done his PhD in Stirling. So that's how I got to know about Stirling. So when a PhD position came available, I applied for it and I was fortunate enough to get it. Yeah. However, I was actually working in more on feed intake physiology. So there was Gordon Bell in the nutrition group, and he was part of my supervisory team. So when I finished my PhD, I was fortunate to move down into the nutrition group, and I think that's probably where all the money is, to be honest. So
it helps.
So when I started working in the nutrition group, it was working on sustainable feeds, but I was also looking at things like the lipophilic contaminants, the PCBs, dioxins.
Let's talk about that. That was 10 years ago, right? When at least 10 years ago, when that big scare about all the PCBs and dioxins in farm salmon.
I think that was about 20 years ago in 2004, to be honest.
Was it that long ago?
Yeah.
So the Hexatal paper, yes.
Is it all cleaned up, or what's the status?
Deal?
Yeah, so I mean, with that paper, it's one of these things. It's the usual thing where the media jump all over it, and it's the sensationalist headlines.
Right.
Yeah.
So that's not what the authors were looking at. The authors were showing that at that time the levels of dioxins and PCBs were much higher in farm salmon compared to wild salmon, even though they were within the permittable legal limits. So, and as I mentioned, media jump on top of that.
Right.
The industry took a bit of a knockback from that, but as the public doesn't always see the amount of research that goes into, behind the scenes work on trying to solve many of the issues. We have to remember aquaculture as it is now, so from its intensive aquaculture, where we think of the cage farms, etc., it's still in its infancy. It's from the 1970s. However, aquaculture per se, we can date back over 4,000 years, and it was mainly those lower trophic species. It's because of the development of nutritional feeds, tailoring those to get the optimal performance for the fish, that the intensive farmed high value species such as salmon have been able to be achieved since the 1970s. So the industry was actually looking into trying to reduce the levels. I mean, 20, 30 years ago, the industry would have known about the levels of fish oil. There's not enough of those for a start. So replacing fish oil with plant-based oils can reduce the levels of these dioxins, PCBs, because they're not really present in in the plant-based ones. There are other contaminants that when we have to do this, we have to think about new contaminants, but concentrating on the PCBs and dioxins, this was all coming from ourselves, humans. Okay, so
we're doing it to ourselves.
Industrial processes, mainly as a byproduct, they can be produced naturally as well from forest fires and volcanic eruptions. But the main production of these into the environment, and particularly into the marine environment, was coming from industrial production, which was always in the northern hemisphere. Okay, makes sense over time. So these found their way. They're very lipophilic, so they love fat. So they make their way into the marine environment, go into the sediment, and when the sediment's disturbed, they go into the organisms, marine organisms, and find their way into the fat content. So when we then harvest those fish and we make them into fish meal and fish oil, obviously the contaminants are going to be quite much higher in that fish oil. So, it's not the fish fault, it's our fault, so we're to blame. So that was an issue for many years, but however, there became techniques where we can actually decontaminate the levels of these contaminants, so we can actually reduce the levels. And that's still being used today just to remove dioxins and PCBs from the fish oils, which are then used in fish feeds, which can then, lower the levels that you find in farm fish. So what you find nowadays, and part of that also is because of the change from fish oil to plant-based oils, is actually farmed fish contain lower contaminants than their wild counterparts.
Interesting. Yeah, let's mention mercury. Let's talk about mercury too, because that always comes up. Mercury in salmon, as I understand it, is not a problem.
It's not really a problem. No, it's normally we talk about it because that's one of the issues with regards to seafood intake. It's it's confusing out there in terms of what is being recommended. We're told to eat 2 portions of fish per week, of which one is oily. But if you are pregnant or if you're of childbearing age, so females obviously, they're taught to limit certain species due to mercury. It's not really mercury, it's the methyl mercury, which is more neurotoxic. What you find is around about 80%, particularly in higher trophic species, of the total mercury is methyl mercury. Lower species, it's probably around about 50%. However, I know you've had Tom Brenner and other people on in the past as well, and they've been showing, and I've actually been reading one of their papers recently, is showing that actually with the cognitive function, EPA and DHA benefits outweigh that from the risk from the mercury. However, from our perspective at the moment, we still have to say, go with what the recommendations say, but we're trying to change that by producing the evidence to say this is why you need to change recommendations.
Right, we agree. Right.
Yeah. It's tricky though. It's not a fun thing to have to decide and stress about. And so that's where, that's part of the reason, like for us, the testing helps clear up that conversation a little bit. And if you want to just use supplements at that point for pregnancy to not have to stress about it as much, that's also been shown to be really good. But fish also, like you said, have so many nutrients that are really important for pregnancy. Yeah.
Iodine is an ever important mineral. So, there's certainly, it's females usually are deficient. It's important, it's important throughout the whole life stages, not only just for the unborn fetus, but for adults as well.
Yeah.
And, in the UK, we don't have iodized salt.
Yeah.
No, but if you're eating haddock, if you eat haddock, a portion of haddock and a portion of mackerel, you'll probably get 2/3 of your iodine intake. So there was a paper I published looking at the seafood species, but instead of EPA and DHA, it's the iodine. Managed to get that one out first. So, the rest of it, I think the rest of the third mainly comes from milk, milk intake. Obviously, if you're eating plant-based ingredients, again, you're going to get that iodine deficiency. So,
yeah.
Yes.
Problem.
Going back to when you were saying selenium as well. So the selenium issue as well, that's another big issue with regards to the replacement of fish meal with plant-based meals. So the plant-based meals, depending where they're grown, it all depends on selenium in the environment. But what we've been seeing is that the selenium levels have been coming much lower as we've been increasing the plant-based proteins in there. So there's issues in there which we're trying to resolve as well.
Interesting. Great.
Yeah. This kind of came out of your background getting into this area, and it sounds like you ended up at Stirling and really found your niche and have been in this area since your postdoc or since your graduate work.
Yeah, so my PhD was 2002 to 2006, and then I moved down to the nutrition group, as I was saying. So that was on the work that they were doing, which they've been doing. So it started off with people like Douglas Tocker, Gordon Bell, James Dick, as you mentioned, John Sargent, big in lipids. So they were working on sustainable aqua feeds and been doing that for many years. So I became part of that group, started working on different aspects. And then it kind of developed that it's looking at the impact of these sustainable feeds, but from the human perspective. So I kind of transect that at the final level of how much is in the flesh of the fish and how much is being delivered to the humans. So as I mentioned, that got me quite curious in terms of current seafood recommendations, and particularly when they state how much EPA and DHA we should be consuming, are the fish actually containing that much?
Yeah.
Another part that I've been working on as well is the GM issue as well. So we've been, for the last 10, if not longer, years been looking at working with a group from Rothamsted Research, a big agricultural research institution. And what they've been doing is to make EPA and DHA into an oil seed. So there's camelina, false flax.
Right.
It's also been done elsewhere using canola, but that's mainly DHA rich. And that is actually being used or allowed for use in salmon. The camelina one, I believe, is going through commercialization as well. So this one contains both EPA and DHA. And we've been testing it in different species from bluefin tuna, sea bass, obviously salmon, sea bream. And I believe it's also been tested in humans as well with Phil Calder's group.
So this genetically modified oil is going to make its way into human food and without getting, demonized, like so many GM products do.
Yeah.
Good, great. That's finally rationality is going to take over.
Well, I think it's all about it's anything GM. It's all about education. It's about explaining to the normal population why you're doing the work. So, in the context is EPA, DHA, as we know, are very important for human health, but it's also important for fish health as well. Levels in seafood are coming down. There's not enough of it. We need to produce more. We can't go anywhere else, really.
Right.
The only other options are to carry on harvesting down the trophic levels like krill, but these are in niche markets because they can then affect the higher trophic species. So it's either microalgae, as we've mentioned, or the GM issues. So over here in Europe, we're probably a bit more tighter on the GM issue, whereas in Chile, for example, it's much quicker to get it through the regulation purposes. So that's probably where it's going to be the main aim, and use will be first before it reaches elsewhere.
That's good news.
That then brings us on to that final thing, is what we're trying to do with the farm salmon. Are we looking to maintain the current levels, or are we looking to increase them back to 5 years ago or even 10 years ago?
Right. And at
present, I can tell you that farm salmon contain exactly the same amount of EPA and DHA as wild Atlantic salmon.
Right.
So, good. Yes. Good to know. Good thing to end on.
Yeah.
It is, yeah.
This was really fascinating. Thank you so much for joining and sharing all this, I think, super useful information. Right. And it's been great. Thank you so much. Keep up the good work.
All right. Take care, Matthew.
Thank you.
Okay, thank you.